let's look to write some differential equations for examples 7 through 9. In example number 7, we see that the rate at which a population is changing is directly proportional to the population itself. All right, so the rate at which the population is changing over time. So that rate means derivative. So we're talking about the derivative of the population. So that's our dp, and it's changing over time. So dp dt, okay? And it's changing at a rate which is directly proportional to the population. All right, so our is sign is our equals, and then directly proportional means that we have our k coefficient, and directly proportional to what? To the actual population, which we're told is p. So we have dp dt is equal to kp. In other words, this is an exponentially growing population. Okay. With number 8, now we have the population of some rabbits out in the woods, okay? And we see that the rate is proportional again, okay? So we have the rate, so that's our d, we're talking about rabbits here, so dr, and their population is changing over time, so dr dt is proportional to, okay, so proportional means directly proportional, which means we have that k coefficient, just like we did right here, all right? And what's it directly proportional to? The product, all right? The product of what? Well, the first thing is the number of rabbits. So the rabbits' population is represented by r, so that's the first thing that we're multiplying it by. What are we multiplying the rabbits by? The difference, all right? Difference we know means subtraction between the population and the max population, and we're told that the max population is m, all right? So we have a difference right there where m is the max population and the actual population is r right there. All right, so there's our, this is actually like a logistical differential equation here. But dr dt is equal to kr times the quantity m minus r. Okay. And then last but not least, we have example 9. The rate of volume is inversely proportional. All right, so the rate that the volume is changing, so that's going to be our dv dt. And it's inversely proportional. So that means we're going to have k over, all right? Inversely proportional to what? Inversely proportional to the cube of the volume. So we have volume, and we have to cube it. All right, so dv dt is equal to k divided by v cubed. All right, so there's some examples that involved direct and inverse proportionality.